Next, next topic, one small topic we'll try to study. That is a LR circuit. What is that circuit here? LR circuit. We have already seen AC generator. We have already seen. We already seen that other things also, how it will current vary and all. So periodic motion EMF, how it will generate and all we study. Now what we study right now is that so if there is possibility, one small condition here, LR circuit, okay, current in a LR circuit. Yeah, I can check. It's on only. Current in a LR circuit. LR means what is it, buddy? L is a resistance, L is a R is a resistance, L is a inductance. Am I correct? Huh? Yes or no? Logic we try to understand. For example, so for a note first we'll try to understand here. What is a node now? For example, logic you should understand. If there is a inductance is connected to a battery, to a cell or battery you can say, and rheostat is also there, and this is a RH rheostat, yes or no? Which you can increase or decrease the current basically, right? So now some EMF, some cell is there, some voltage you are trying to supply. So current will be passing, this is applied current will generate. How much it will be? Applied current will generate, right? So this is what you are trying to pass through this one. So what happens now? Logic you should understand here. So whenever this is an inductance, how much here? L. Whenever you try to increase the current, what happens here? It will rise to oppose with the induced current. What is this one here? It tries to oppose the current. Yes or no? So, am I correct here? So, what is it I will try to write now? If applied current, what is the I told you? I is the applied current. I is the applied current. What is this current here? Applied current. If you are increasing, means if you try to increase the current, applied current, now what happens here? Induced current is also tries to opposes and it tries to increases. Yes or no? We studied that already. So how much current you can actually increase? You cannot completely pass the current. Immediately you cannot increase. It will tries to resist you. It tries to what happens, buddy? Tries to resist you. So resistance, if I see that is because it will take some time to increase or not. So how do you increase it? We have already seen there is a graph of a sine graph, cos graph and all. When left man. If you try to increase the time with respect to time, yes or no? Because the time is changing here and this is the current. What is this one here? The total current you want to change. Now how it will vary now? It will not vary immediately. It will vary like a, it will vary very slowly. Like we have seen already a graph of how periodic function will change. We have seen, right? How it vary now? It will vary like this. To the maximum extent, this is what we studied, right? Yes or no? To the, so it will vary like this and it will reach to what is that here? Maximum current I naught it will vary while you are increasing. We have seen, right? Yes or no? So if you remember AC generator, we have told you that the current will rise like this and right, it will change or not. So it will change to what is it here? Maximum current is what is it here? While increasing, it will increase this much current only, which is I told you this as a peak value. What is this value here? Peak value. Are you getting my point here? When you what increasing? Clear? Now similar way, how much it will increase? If I try to show you now. So if I increase, if I show you the value will be increased is how much now? 0.63 times of I naught. What is at any instant if you wanted to find? For example, here you wanted to find the current. So at any point like you want to check now how much increment you can see? 0.63 times of a peak value it will increase. Clear? Same way, now it is a case 1. Now case 2. Case 2, what is the case 2? If you want to reduce the current, what happens, buddy? If you want to reduce the current, will it allow us? Will it allow us? No. It will not allow us, but it will act in opposite direction. Yes or no? So it reduces. Now what happens here? It tries to oppose that also. It will increase in opposite direction. Increase in opposite direction. How much increment you can see here? Simply I can try to draw that graph also. It will decrease in this manner. This is the current versus time if I try to show you. So here how much decrement it can see? You can see that. So it will show you from the peak value. It will try to decrease like this. Got it? How much decrement you can see here? So at any point you want to check na decrement like this any point na I value will be how much it will decrease here 0.37 times of I naught it will decrease. Got it? So this is what is this one here? Increment. Increase of current. This will be what is this here? Decay of current. Yes or no? Note down. Not right. You take it. You should carry on Eno every time. Done, buddy? Any difficulty? What happened? Right? Please note down fast. So finished. Next, write down one more point here. You finished, right, this part? Note down, note down. Anybody? So now here itself few other points also I would like to write. So one formula we need to remember it. Did you finish this part? Yes or no? Okay. Now what I'll do now? I'll connect one of the resistance here. Okay. I'll connect the one of the resistance here. So earlier was only one inductance. Now I'll connect one of the resistance here and one inductor here. Is it okay? What is the resistance here? R. Right? Now in this situation also what happens? The current will increase like this only. So what is that I can write a same graph I can draw, right? At any instant, rise of current. Rise of current means increment in a current. How do you find na? Rise of current, you have to remember the formula. I is equal to I naught times of 1 minus e power minus r divided by L into t. Okay, e power what is that here? Minus r divided by L into t. In the similar manner here, in a decreasing current, same diagram at any instant decay of current. How much decay will be there, which is I times of I naught times e power minus r divided by L into t. Got it? No need of derivation, sir, but directly remember the form. Got it now? Earlier what I did? So just we are adding one resistance in front of it. Right? Note down. So time constant we have it, which is nothing but denoted with the tau. Time constant is nothing but here tau is equal to r divided means L divided by r. Time constant will be what is it here? L divided by r. Yes or no? I can write. So this entire formula what can I write here? I naught times of 1 minus e power what is that rate? So minus t divided by tau I can write it. Or else here also what can I write here? I naught times of e power minus t divided by tau. Tau is a time constant because L and R it will be what is that here? A time constant. What is this I, buddy? I is called as a induced current. What is this one here? Induced current. Julian, give me water bottle. You need? So increment how much increment you can see? 63% you can increase. Decrement how much decrement you can see? 37% you can decrease. Yes or no? Here also I can write. So what is this I at any instant? How much we will get it here? I is equal to 0.63 times of I naught times it will come. This is the increment you can see. What is the decrement you can see? This one. I is equal to how much here? 0.37 I naught. Means Increment you can increase only 63% in the inductor. You can decrease the current only 37% only decrement you can see. Clear? You cannot do 100% increment. You cannot do 100% decrement. Clear? Are you getting my point, buddy? So that is the main thing in the LR circuit. LR circuit that is a important concept. Shall I? Next. I hope all the concept was clear with it. Raghavarshini, I am here. Screen is here. What are you watching it? That box. Whom you are watching? You are also planning anything? Supporting character, anything is there? Where is that lady? Shall we move on now? Next, one more important thing we will try to tell you. Eddy current. What is this current here? Eddy current. Eddy current is also called as a induced current. This is very important. Now, I'll tell you some important points. Josha is there. Yes or no? Yes or no, Josha? After 10 years, she became a famous cardiologist. Yes or no? When they become cardiologist, they'll buy Audi car. Audi car, have you seen it? Yes or no? Audi car, famous car. She bought it, fine. Why? Why? For purpose of showing no. Audi car can do something here. If suddenly she was driving one car, the car, Audi car is very smooth car like this. Q series she bought it. Okay. And in front of it, for example, one buffalo came. Is that possibility there, right? Okay, possibility there that buffalo don't know anything. Innocent. Like, I don't want to take the name. Innocent like this, one buffalo came. Now what happened here? She was driving, right? She's a famous driver. Yes or no? Will she able to control this much big car? No. But this car has certain technology. What is that now? It automatically can give a brake system. Yes or no? Same thing, Devadarshini bought one Suzuki car, Alto, basically, which has only 4 tires. In front of, tell me, what happened? In front of her, I came, okay? Suddenly, got it? This is a Alto car, buddy. Which car is this one? Alto. This one is a Audi. Audi and Alto difference was there. So now tell me, which car will save the person? Here buffalo, animal, here me, fine. Which car will save the person, buddy? Audi or Alto? Alto never save. Okay, don't tell like that. That's a lie, okay? Audi car will save the people. Reason? Reason is there. Reason because they have utilized the eddy current very well. And you have a braking system. What is it here? A braking system, you can automatically brake it. Means if it will automatically, sensors are there, by sensing it, it will stop. Whereas this Alto car, okay, so this person will be RIP soon. Because there is no such a sensor and all, okay, and she'll never control, obviously. Will you control it? Never. So this person will be RIP. Got it? Why like that? So technology is there called as a eddy current. What is that one? Eddy current. Eddy current is very important. It automatically controls the technology. But for your standard, will you study this much? No. You don't know all this, okay? So what we'll do now? We'll try to do with a simple experiment. I'll try to show you this eddy current. Eddy current. So what is this eddy current now? Now listen, but logic you should understand. So two cases I'll tell you. Based on that you inform me. One case is that we are applying one north. This is north pole, and this is a south pole. South pole. North and south magnetic field is there. Now what happens here? There is one a pendulum I am trying to take. Which pendulum here? A solid pendulum I am trying to take, like a spoon. Okay. So now spoon, what is that now? Whenever you are bringing. So for example, the spoon is coming from to, when it comes here, it automatically stops. When you are going like this, you are leaving it, automatically it has to be making angle theta. This like this, it is trying to rotate. It has to oscillate, right? Pendulum should oscillate. But what happens here? It will automatically stops. Why? Reason is simple. You know already magnetic field is there like this. The conductor is moving in this direction. Current will generate or not? Which direction current will generate in this one? Tell me. Use your hand and try to show me. Which hand here? Right hand. Magnetic field which direction, buddy? Like this, north to south. Yes or no? Conductor direction in which direction? Like this. Magnet. Now current will generate upward direction or not? Means here in this pendulum automatically current will generate in this manner. Yes or no? It has to be last or not. So what it will do? It will rotate like this. It will make a wheeling situation. Are you getting my point here? If you see in this one, if you see here, if I see this is a pendulum now, current will be generated like this now. This current will be like this, like this, like this, like this. It will move. It is called as what is this? Will pull, right? Yes or no? The current will automatically go into it. So if this is comes from the certain distance here, certain distance let it come, but automatically due to the induced current it will stop. Got it? Automatically it will stop. Are you getting my point? Now same situation I am trying to create. This is a case 1. This is called induced current only, no? Or what we can call it as a eddy current. What do you call this one? Eddy current. Now one more situation here. Same magnet I am taking here, same sort of magnet. Now north pole, here south pole, right? But here the pendulum whatever you are taking, this pendulum is made holes, certain holes you made it. Yes or no? You made certain holes to the pendulum. Like this, you made some holes. Now when it reach inside this one, now it will come inside or not, like this. How it will came? From there it is coming here. Now what did you do? What did you do? You made some holes in it like this. You made a hole. Now what it will do? It will not stop. It will not stop. Reason? It will come here. It will oscillate. It will oscillate. This will stop the oscillation. This will oscillate. Why, buddy? Because these holes are there, no? This hole is not allowing this sort of pattern. Whereas this one is allowing the hole pattern. Are you getting my point here? Now, is it very clear? Now, this is fully filled with the material. It has a holes, something are there. So, you cannot create this pattern. So, what are you doing here? You are breaking the entire pattern of eddy current. So, you cannot actually make the strong eddy current there. What is this one here? It automatically can oscillate. Yes or no? Even though here also it will generate, but you are stopping it due to the holes. Why? You see, like this there is a holes you made it. Am I correct here? Now when it comes in a magnetic field, automatically it will generate a current, yes or no, anti-clockwise. What it will do, it will try to go like this direction and then it will try to enter in. Now what happened here? No material. So it will stop. So it has to slow down and it will come again. It has to do. Till then it will move. Move from that magnetic field. Are you getting my point? So eddy current you understood, right? So this eddy current is many, it has advantages as well as disadvantages also. That is your homework. You have to study advantages and disadvantages of eddy current by your own. Clear? Advantages is main advantage I can say you can immediately break certain things. Yes or no? For example, in your book already there are list of advantages already mentioned. Okay, you just go through it, you can understand it. Okay, advantages like electrical brakes, as I told you just now in a cars, electrical brakes, induction furnace, energy meter, speedometer, all those things, eddy currents will be used. Disadvantage is also there, like in a transformer, you have a disadvantage. Okay, there are advantages and disadvantages. You have to study about it. Is it clear? Electrical brake, though, I don't think you'll forget about it. Yes or no? Electrical brake, electrical furnace, all those. Why electrical brake is important? For example, you might have been seeing many videos of YouTube, right? So people will use for cutting. Now, for example, some butcher is there who is cutting the meat or some potato or something like that. Yes or no? In restaurant. So that automatical knife will be rotating or not? It will be working. So that person, whenever his finger comes nearby it will stop automatically. Yes or no? That's a sensor we can say. But sensor is working on what pattern here? Eddy current. Whenever your hand comes, automatically it will stop. Now you see automatic doors in a shopping mall or you can say cinema theater. When you go, no, automatical door opens, right, and it will close it. Or else taps also there. When you put your hand, automatically water will come, and whenever you it will stop. Such things. Yes or no? So mostly the sensor will work on what process here? Eddy current. Clear? I hope you are very clear with it. Yes or no? Shall we do the questions now? Okay. This is also there in the exam. Eddy current you study by your own. Now do this question fast. What akka? Do the question. Okay. This after this. Calculate a current which given by battery following circuit. Just after closing a key, Harini will do it. Yes, na Harini? Do it. Sometime after closing a key. With this, almost your chapter is over. Okay, we will do few lot of questions in it. Then we'll stop it. Okay. So I have a question. This one, just after closing a key. Just after closing a key, na, what happened, buddy? What happened? Immediately, now for example, the current is going through this. You see, this is a pattern of the circuit. Here you have a 5 Henry. Am I correct here? Here you have a 6 ohms, 3 ohms, and then you have a 2 ohms, and then a 10 volt. Yes or no? Now one simple thing you want to tell me. Will this circuit, for example, the current is gone through this one is I current is passing. Now when it reached to this point, what happens? It will divide according to the Kirchhoff's law. Am I correct? I1 and I2. Now you tell me something here. This immediately after closing a key, will you rise the current this side? No. It will not allow current. this inductor will not allow current through it. Yes or no? So what happens here? I1 will completely become 0 here. In this situation, I1. So this circuit, you cannot pass a current here. Immediately you cannot increase the current. Yes or no? What happens here? This will be open circuit that time. So automatically what is this here? Only this circuit is live that time. Clear? Then what is the answer now? So that time here only this answer. So R equivalent is equals to only this circuit will work. Yes or no? What is the R equivalent here? 2 plus 3 will be how much here? 5 ohms. So current will be equal to what is that now? Voltage divided by resistance equivalent. Voltage is 10 divided by 5. Total answer will be how much here? 2 amperes. Am I correct? Then second situation sometime after the closing a key. Sometime after the closing a key, now what happens here? You can actually rise the current. Okay, you can actually rise the current, but what happens here? This inductor no longer useful after that. Yes or no? It will allow pole current, but initially it will stop the current. After that, what happens here? It will allow the pole current. So now that time what happens here? It will be now common. I cannot take any resistance. Clear? So now what happens now? Tell me. This is 2 ohms. This is 3 ohms. This is 6 ohms. That's it. Right or no? Next situation, what happens here? This circuit I can make it as already 3 ohms. There is one more, this one. So no, they are parallel. So that this is. So this is 2 ohms, and remaining what is this here? 6 ohms, 3 ohms, and this is a 10 volt. Now what is it you are asking here? Sometime after the closing the key, it will allow pole current action. Yes or no? How much current is that? Can you just calculate? R equivalent value will change. Okay, so that is your homework. Try to do it. You will see the total current passing. Yes or no? Understood? After some time, it is no longer it will stop the current, but initially it will stop the current. You can move now. You can try and tell me tomorrow answer. Chalo, bye.